All right, we're jumping to Chapter 8. But we're in the geometry book, Chapter 8. But I'm just going to give you worksheets like I have been before, so I'm not even going to worry about giving you a book on this. But you got to take good notes. That's the thing. Okay, if you don't take good notes on this stuff, then it's going to be very difficult. And don't just rely on YouTube because, you know, 0.0012100 views on my YouTube videos show that not everybody is relying on these things, okay? So you should take your notes. And that could be an indication maybe why the tests were the way they were, just because of the number of views. What's that? They don't count as what?
Like
what?
If you watch on your phone, it doesn't register.
Oh, the views you mean? Oh, is that right? Okay. Well, maybe that's what it is. Well, hopefully you're using it. Well, what we're going to do right here, Section 8.1, this chapter is basically about trig. It's trigonometry. You ever hear that? Trigonometry. And that's what we're going to do. We're going to, it's about, the beginning of it's about right triangles, but then we get away from right triangles a little bit towards the end. But they're all based, even when I say we're getting away from right triangles towards the end, it's all based on right triangles. Those equations are based on right triangles. Anyway, enough talk. Let's do this. First thing we're going to do is talk about a thing called the geometric mean. Geometric mean. Doesn't mean that geometry is mean. It's kind of like, I can't even give you like a good, yeah, it's kind of like mean, median, and mode, where mean is the average, but it's a geometric average. It's not like a true arithmetic average. So it's not like if I take two numbers, add them up, divide by 2, that's the average. That's not really what we're talking about. Okay, it's a geometric mean. I can't really give you an explanation that you could sit there and understand, but I can show you how to use it. All right, and that's what we're going to do right now. So what they're going to do is they're going to give you two numbers. Let's just make up a number. Let's say 2 and 7. Alright, let's go to a color here. Go to purple. Alright, so if they give you two numbers, 2 and 7, what they're going to do is they're going to say, find the geometric mean. I'll just shorthand it, alright? Find the geometric mean between those two numbers. If I could write, that's supposed to be a W-E-E-N. Okay, find the geometric mean between 2 and 7. That's the question they're going to ask you. And that's going to be the very first question on the test. You hear me? You writing all this down, Judah? Okay. How can you write down with your hands all inside your sweater like that? Sure you are. So that the grade on that test made no impact on you as far as maybe taking notes this time? Oh, okay. Well, it might help if you took some notes. I'm not actually asking you, I'm telling you to. Okay? I was just trying to be nice, but you just refuse to. So I'll come right out and say, I'm telling you, you have to take notes. So watch, find the geometric mean between 2 and 7. So watch what we're going to do. A geometric mean is basically a proportion. A proportion, we've talked about proportions, haven't we? Have we talked about that? Okay, a proportion are two ratios or two fractions set equal to each other. Okay, now it says find the geometric mean. I'm going to use x for the geometric mean. You can use any letter that you wanted to. Alright, I'm going to use x on this one. So first thing we do, this is our little formula right here. These are fraction bars. I'm going to have something over something equals this over this. You got it? So the geometric mean is x. I'm going to put the x right here. But this is a little unusual because usually if we have a formula, you just are solving for that one thing. I'm going to put an x here and I'm going to put an x right here. Are you watching? Okay, because I'll tell you from experience, okay, just this year, I've taught this twice already to my other 2 geometry classes, actually other 4 geometry classes, and this was the first question on the test. And I might have even used these exact numbers. I can't remember exactly, but it really doesn't make any difference. And I still had people leave this blank or not even have a clue how to do this. And this is the first thing that I taught them. You go back and look at the videos from my geometry class, you see the first lesson that I taught was this, and when it came to the test, people still didn't even write anything down. That's just, to me, that's just unbelievable. I just don't understand how that can happen. But, you know, they just didn't care. They just didn't study. They didn't take any notes, all right? That's why they couldn't get this right. So you be different, all right, and you get this right on the test, all right? We're going to use this quite a bit. Not just on this particular problem. This is as easy as it gets. We're going to apply this a little bit later. So here we go. We put the x here and the x here. It represents the same number. Okay, it's x. It's not two different numbers. This can't be 3 here and 7 here or something like that. Okay, it's one number. You follow me? Now, where do you think you're going to put the 2 and the 7 then? The other two spaces, exactly right. Okay, put the 2 here and put the 7 right here. And now we can actually solve for x. We've done cross multiplying before, haven't we? Okay. Doesn't matter where the 2 and the 7 go, because if we're going to cross multiply, look, 2 times 7 or 7 times 2 doesn't make any difference, does it? Now, but you do have to have them diagonal to each other. Do you see that? The x and the x have to be diagonal, and the two numbers that they give you, they have to be diagonal to each other. Don't put the x on top and the x on the bottom. That wouldn't make any sense, because that would be 1, wouldn't it? And then the x would just go away. You can't do that. You put them across from each other. So now we can cross multiply. So I get x squared equals what? 14. And now we solve for x. How do we solve for x? We've done this before. Square root both sides. So x is what? Yeah, we're actually not even going to do the plus or minus this time, because what we're going to do, this geometric mean is actually, we're going to be finding the lengths of segments. Alright, so I can't have a length of a segment that's negative anything, can I? So you're right, technically you would put a plus or minus there, okay, but we're eventually just going to find the lengths of segments, so we're just going to use the positive version of this. Okay? Alright, so that would be your answer right there. Easy. Wouldn't you agree? Yeah. So if they give you two numbers, just put it here and here. Put x here and here. X represents the geometric mean. So you put it right here, and you're good to go. Make sense? Alright, good. Let's, Alright, let's just go to the next thing. Let's see how this works. Let's see why in the world would you want to even find this thing, because that's probably what you're thinking, right? Okay, yeah, I know how to find the geometric mean, but how does that apply to anything? Well, I will show you. But thanks for asking that question, because that's a good question. Alright, actually. What we're going to do is we're going to start off with a right triangle. And I'm just going to make it real big like this. Okay? So this is a right triangle. Right there. Now what I'm going to do, this geometric mean stuff works only in this one situation. Right? It's a situation that I don't know, I don't know how often it occurs, but it occurs from time to time. Let's do this. Let's make it right here so that what I just drew right here was perpendicular to the hypotenuse. Did you see we had that big old right triangle? This side from here to here is the hypotenuse. Right? So what I did is I drew a line segment from the right angle over here to the hypotenuse. Everybody see that? We call that the altitude. I don't know if you remember that, but again, I taught this in geometry, and so that was a word that we discussed quite a bit in geometry, is the altitude. If you go from the right angle, or if you go from any angle perpendicular to the opposite side, we call that the altitude. Alright? So what I'm going to do now is I'm going to put some letters in here. The first three I'm going to put in here are actually the geometric mean. So it's kind of like x. Remember on that problem we did earlier, it would be x. So I'll call this x. So that's a geometric mean. So this segment right here, drawn to the hypotenuse, that is a geometric mean. Okay? I just don't know what numbers it's between, right? Remember before it was between 2 and 7? I just don't know that. I'll show you that in a second, though. This right here is also a geometric mean. I just call it side A. Is that all right? And then this side over here is also a geometric mean. So these three things in color are all three geometric means. So that, and that are all geometric means. So if I said, find the geometric mean, well, A would be a geometric mean, wouldn't it? So if I was going to set this up, I would go, watch, if A is a geometric mean, where would I put A in my little formula here? Put one here and what here, right? But then I got to figure out what two numbers. I don't have any numbers here, do I? But once I get some numbers here, I'm going to put a number here, I'm going to put a number here, and then I can solve for A. Does that make sense? B is also a geometric mean. So what would I do here? I'd put a B here and a B here, because that's a geometric mean as well. Well, X is also a geometric mean, so how am I going to set that up? Another two fractions, right? Put an X here and an X here. My only problem is I got to fill it in with some numbers. Don't know any numbers here, do I? Yeah, but I don't know any lengths of sides. I don't care about the angles because these numbers don't represent angles. They represent lengths of sides, okay, or lengths of segments. All right. Let's do this. Let's say that's 2. I'll use those same numbers that we used earlier so that it's familiar to you. And we'll change colors. That's 2, and let's say that's 7. You with me? Okay. Let's do x first. X is the easiest one. Tell you what, let me get rid of all this junk right here. We'll clean it up a little bit. Get rid of these arrows. We did this? In here? Ah, when we did the, is that right? So this should be familiar then. I don't even remember doing it myself. Alright, well let's take a look. X is a geometric mean. Alright, so what we're going to do, now I wrote those out already, but I'm going to do it again. I'm going to put X here and X here. X is a geometric mean between what and what? Okay, well I'll show you. Alright, it's between the two segments of that big hypotenuse right there. See the whole big triangle and the big old hypotenuse? So X is a geometric mean between the two segments. See how this altitude splits this hypotenuse right here? Okay, so this little bit is 2, and from here to here is 7. Alright, so the X is the geometric mean between the two segments of that whole big hypotenuse. Get it? So the whole hypotenuse is split. It's not split in half, is it? Because I got a 2 and a 7, but it's split. Okay, between this little part, which is 2, and this little part is 7. So what do I put here? 2 and 7. And then I can solve for X. You already know what that is because we just worked with that number, didn't we? So that's how you find this geometric mean. Tell you what, let's do this. Just to make it a little more color coordinated. Is that alright with you? So the geometric mean is in orange. You got it? Can you see the difference between orange and yellow? Yeah, you can. Okay. We good so far? What else is a geometric mean? A and B, right? So let's do A next. So A is a geometric mean. So if A is a geometric mean, what do? We set it up like this, don't we? Alright, so A goes here and A goes here. Why does it go right there? Because A is the geometric mean. That's where you put the geometric mean. Now, this is something that I wouldn't expect you to know just off the top of your head, but I'm going to tell you. These sides, A and B, now watch. It's a little bit more difficult than what X is. It's not much. Just kind of get used to it. A is the geometric mean between the whole entire hypotenuse. Well, what would the whole entire hypotenuse be? It would be 9. That's right, because that's 2 and that's 7. The whole thing would be 9. Would you agree? Okay. So this side, this leg of the right triangle is a geometric mean between the whole entire hypotenuse, which is 9, and the segment of the hypotenuse that's adjacent or next to this side A. So is 2 or 7 next to A? The 2 is. Alright, so A is a geometric mean between the whole thing, which is what? 9. The whole thing, which is 9, and the segment of the hypotenuse that's adjacent to side A, or next to it. So it's just between 9 and 2. See it? It's between the whole thing, 9, and the part of the hypotenuse that's closest to A. And 2. Which one's closer to A? 2 or 7? 2 is. It's adjacent to it, right? It connects it to the A. The 7 doesn't even connect to this A at all, does it? You see it? So A is a geometric mean between the whole thing and the segment that's closest to A, where it's adjacent to it. So 9 and 2. And now you can cross multiply and solve for A. Well, B works kind of the same way. B is also a geometric mean. So that goes here and that goes here. Between what and what? Well, it's very similar to A. So B is a geometric mean, what do you think? Between the what? The whole thing, which is 9, and the segment that's adjacent to side B. So between 2 and 7, which one's adjacent to B? 7 is. So it goes right there. So that's how you set this stuff up. It's not so hard, is it? So let's do the math. The math is the easiest part of this. It's setting it up is the part that you got to know what to do. So watch, cross multiply. So that's x squared equals 14. Take the square root. X is the square root of 14. Just leave it like that. Don't give me a decimal. Just leave it like that. See how I circled it? That's how I want you to leave your answer. Just like that. We good? Let's do this. Let's solve for a. Cross multiply. A squared equals. Now watch what I'm going to do here though. Show you a little trick. Have we done much on simplifying square roots in this class? Okay, so let's do it like this then. Watch, I'm going to take the square root of both sides, right? So that goes away. Take the square root of this. Watch why I didn't multiply them together, because it's a lot easier the way I'm doing it right now. Watch this. A equals. Remember what we do here? If you have two things that are multiplied under a square root, I can just take the square root of each of these individually. All right, that's a rule in Algebra 2 that we've learned. So it's the square root of 9 times the square root of 2. Well, what is the square root of 9? It's just 3. What about the square root of 2? Just leave it like that. There's nothing I can do with that. All right, so that's what A is, and that's how you should write A. That's the simplified version for A. We good? Ryan, you getting all this? Taking good notes? Looks like you're doodling. Look. Dude, if I would... I'm pausing. Here we go. B squared
No, he's not. He's no idea what-
equals this. 9 times 7. So look, take the square root of both sides. Are you guys watching? Come on, we're done with that. Let's take the square root of both sides. So that'll go away, right? Take the square root of this side. So B is, yeah. So I'm going to write it out, though. It's square root of 9 times the square root of 7. And B is 3, what? Times the square root of 7. And there you go. Nice pretty answers. There's no decimals. Do you see any decimals? I see no decimals. Okay? Don't want to see any decimals with this. If I see decimals, it's going to be wrong. You hear me? Decimals equals wrong. How's that? Alright? I don't want to see any decimals. These are exact simplified answers. That's how I want to see your answers. If I could spell right. Did I spell that right? Simplified. Okay. Okay. They need to be exact and they need to be simplified. When I say exact, the square root of 14 is an exact number. If I was to put this into a calculator, I wouldn't have an exact number. I would have some approximation. So a decimal would be an approximation because this decimal would keep on going forever and ever and ever and it would never stop. That means there's no exact number that square root of 14 is actually equal to. Alright, so what do? I write it as square root of 14. That's considered an exact number. That's considered an exact answer. Yeah, you get it? This is simplified right here. You could go square root of 18, right? Because 9 times 2 is 18. But that's exact, but is it simplified? No, it's not. This is simplified, and it's exact. Same thing here. I could have gone square root of 63, couldn't I? So technically it's the same number as this. It's the same value as it, but it's not simplified. That's right. That's simplified. That's the kind of stuff that you're going to do on this. Think you can handle that? Okay. Go through it again. Look at your notes, because your notes are all you need. But if you need to, go back, listen to my explanation of this. Watch. This altitude is a geometric mean between the two segments, 2 and 7. The two legs of my right triangle are geometric means between the what? The whole thing and the segment that's adjacent to that leg. If you can remember that, you should be able to do these. Let me give you a worksheet.